Hello and welcome back to Chopstick Maths. Differential equation exercise 8 sum number 7. The given differential equation is d square minus 4d plus 4 into y is equal to 8 into bracket x square plus sine 2x plus e raised to x square. Now the general form of this differential equation is f of d into y is equal to capital X, where f of d is d square minus 4d plus 4 and capital X is 8 into bracket x square plus sine 2x plus e raised to 2x. The solution to such a differential equation is y is equal to CF plus PI, that's a complementary function plus the particular integral. That is, the solution has two parts. So let us first find the complementary function. To find the complementary function, we have to equate f of d is equal to 0. That is d square minus 4d plus 4 is equal to 0, and we can also call this as the auxiliary equation. Now we will factorize this, that is it would be d minus 2 into d minus 2 is equal to 0. So the roots of this equation are d is equal to 2, 2. So if you see, the roots are rational and repeated, so the CF is equal to C1 plus C2x into e raised to 2x. So now let us proceed to find the PI. Now PI is equal to 1 upon FD into X. That is, PI is 1 upon d square minus 4d plus 4 into 8 into x square plus sine 2x plus e raised to 2x. That is, we can now write this as PI is equal to 8 upon d square minus 4d plus 4 into x square plus 8 upon d square minus 4d plus 4 into sine 2x plus 8 upon d square minus 4d plus 4 into e raised to 2x. Now if you see, the PI has three parts because there are three different functions. So we shall call it as PI is equal to PI1 plus PI2 plus PI3. So let us first find PI1. PI1 is 8 upon d square minus 4d plus 4 into x square. Now if you see, it is of the type PI is 1 upon f of d into x raised to m, where x raised to m is x square. In this case, we will have to express f of d as 1 plus phi of d. So f of d here is d square minus 4d plus 4. So we shall express this as 1 plus phi of d. To do this, we'll have to first reverse the order of this expression. So we can write this as 4 minus 4d plus d square. That is equal to 4 minus into bracket 4d minus d square. Now we'll have to get a 1 here. So to get a 1, we'll have to multiply and divide by 4. So this will be equal to 4 into bracket 4 minus into bracket 4d minus d square upon 4. So this would be 4 into bracket 4 upon 4 minus 4d minus d square upon 4. Now this would be 4 into bracket 4 and 4 would cancel, 1 minus 4d minus d square upon 4. Now if you see, this is of the form 1 plus phi of d, where phi of d is 4d minus d square upon 4. Now we can substitute this here. So PI1 would be 8 upon 4 into 1 minus into bracket 4d minus d square upon 4 into x square. Now we can bring this up in the numerator. 8 and 4 would cancel. So this PI would be 2 into bracket 1 minus into bracket 4d minus d square upon 4 the whole raised to minus 1 into x square. Now we will have to expand this particular expression, which has a power of minus 1. And we can do this using 1 minus bracket raised to minus 1 is 1 plus bracket square plus bracket cube and so on, where the bracket here is 4d minus d square upon 4. Therefore, PI will be equal to 2 into bracket 1 minus bracket 4d minus d square upon 4, the whole raised to minus 1 into x square. Now you can expand this expression 1 minus into bracket 4d minus d square upon 4 the whole raised to minus 1 using the formula 1 minus bracket the whole raised to minus 1 is 1 plus bracket square plus bracket cube and so on. Now here the bracket will have the term 4d minus d square upon 4. So now let us expand. Pi is equal to 2 into bracket 1 plus bracket, that is 4d minus d square upon 4 plus bracket square, that is 4d minus d square upon 4 the whole square into x square, and we shall neglect the higher powers. So pi would be equal to 2 into bracket 1. We'll open this bracket, so this will be 1 plus 4d upon 4 minus d square upon 4 plus, now we shall expand this using a minus b the whole square. So that would be 16d square minus 8d cube plus d raised to 4 upon 4 square is 16 into x square. Now pi would be 2 into bracket 1 plus 4 and 4 would cancel. So this would be 1 plus d minus d square upon 4 plus 16d square upon 16. Now we shall neglect the higher powers of d, that is d cube and d4, because d is the differential, that is the first order derivative. So d of x square, the first order derivative of x square will be 2x. D square of x square, that is the second order derivative of x square, will be 2. And d cube of x square, that's the third order derivative of x square, will be 0. So we will neglect d cube and d4. So we will neglect d cube and d raised to 4. So pi will be equal to 2 into bracket 1 plus d minus d square upon 4 plus 16d square upon 16 into x square. So pi will be equal to 2 into bracket 1 plus d minus d square upon 4, and 16 here would cancel out each other. This would be plus d square into x square. So pi would be 2 into bracket 1 plus d plus, adding these two like terms, we'll get plus 3d square upon 4 into x square. Now opening the bracket, pi is equal to 2 into 1 into x square is x square, d into x square is plus d x square plus 3d square upon 4 into x square is equal to plus 3d square upon 4 x square. So pi would be equal to 2 into bracket x square d of x square, that is the first order derivative of x square will be 2x. So this would be plus 2x plus 3d square upon 4 into x square, that is d square of x square, that is the second order derivative of x square, is equal to 2. Therefore this will be equal to 3 upon 4 into 2. So pi would be equal to 2x square plus 4x plus 3. So pi1 will be equal to 2x square plus 4x plus 3. So we have now calculated pi1. So let us proceed to calculate pi2, which is 8 upon d square minus 4d plus 4 into sine 2x. Now here you see there is a d square. So you can use this particular property. If pi is 1 upon 5 of d square sine ax, then pi would be 1 upon 5 of minus a square sine ax, provided 5 of minus a square is not equal to 0. So we can substitute d square as minus a square. Now you see here a is 2. So pi2 would be 8 upon minus 2 square minus 4d plus 4 into sine 2x. So minus 2 square, which is minus 4, and 4 would cancel out. So you'll have pi2 is 8 upon minus 4d into sine 2x. So pi2 would be 8 and 4 would cancel out. This would be minus 2 into 1 upon d sine 2x. Now as we know, 1 upon d is the integral. So pi2 would be minus 2 into integral of sine 2x dx, and integral of sine 2x dx is minus cos 2x upon 2. So pi2 would be equal to minus 2 into bracket minus cos 2x upon 2. This 2 would cancel out, and minus would be plus. So pi2 would be equal to cos 2x. Now let us calculate the third part of the particular integral, pi3, which is equal to 8 upon d square minus 4d plus 4 into e raised to 2x. Now we can use this property. If pi is equal to e raised to ax upon f of d, then we can substitute d is equal to a, that is pi will be equal to e raised to ax upon f of a, provided f of a is not equal to 0. Now f of d is d square minus 4d plus 4. Now a is 2, so f of 2 is equal to 2 square minus 4 into 2 plus 4, which is equal to 0. Now f of 2 is equal to 0. So we can't use this property. We'll go to the next property. That is, if f of a is 0, then pi will be equal to x into e raised to x upon f prime of a. That is, we'll have to find the derivative of f of d. Therefore, f prime of d is equal to derivative of d square is 2d, derivative of minus 4d is minus 4, and derivative of 4 is 0. So f prime d is 2d minus 4. Now that is, we'll have to now substitute d as 2. So f prime 2 is 2 into 2 minus 4. Now that is again equal to 0. So we can't use this property as well. We'll have to go to the third property. That is, if f prime a is equal to 0, then pi is equal to x square into e raised to x upon f double prime a. That is, we'll have to take the second derivative of f of d. That is, f double prime d is equal to 2. That is the second derivative of f of d. That is, derivative of 2d is 2 and derivative of minus 4 is 0. So f double prime d is equal to 2. So f double prime 2 will be equal to 2. Now if you can see that f double prime 2 is not equal to 0, so we can use this property. That is, pi 3 is equal to 8x square into e raised to 2x upon 2. Now here this would cancel, so it will be 4x square into e raised to 2x. Therefore, pi is equal to pi1 plus pi2 plus pi3. Therefore, the particular integral pi will be equal to, as pi1 is 2x square plus 4x plus 3 plus pi2 which is cos 2x plus pi3 which is 4x square into e raised to 2x. Therefore, the complete solution y will be equal to cf plus pi. Therefore, y is equal to c1 plus c2x into e raised to 2x plus pi which is equal to 2x square plus 4x plus 3 plus cos 2x plus 4x square into e raised to 2x. That is the complete solution of the given differential equation. Thank you very much.